Okay, so since this is the very first chapter, I'll kind of preface it by adding a few things here. So this is what um, spring semester 2024. Um, this is I've taught this class for a very long time, as many as I indicated before. But using chapter by chapter homeworks is a little bit new for me. Typically, I've done the problem set method. But one of the issues that emerged, I think, was that some students wanted more frequent opportunities to do homework. So the idea here was more frequent opportunities. But one of the things that I realized in talking to some of you was that these homework questions can seem a little bit frustrating if you don't have any tips about how to start to solve things. Now, I don't know, I've been debating this in my head for about the last week here before making this video, and I've decided to do a kind of a hybrid method here. I'm going to talk about each of the questions in the homework, but I'm going to try to refrain from explicitly saying the answer. Rather, I want to give enough detail to you so that solving the homework isn't as challenging and frustrating as it otherwise would be. Um, I'll try to keep the video short to an hour or less for each chapter. And basically, my preparation for it was that I turned the homework assignment into a PDF that I'm showing you right here. And then I basically solved it. I wrote some notes for me on the side. And basically, I'll kind of talk to you about those notes. Okay, so let's start. First one we have here, oh, and I should say this too. The homework system tries to do things algorithmically. So the numbers that I see or the directions of changes that I see when I printed this out might not be the same as yours. So just keep that in mind. Okay. So in chapter 2 in general, we're talking about just the nature of the supply and demand function. I'll pause here. Okay, so in question number 1, we're talking about the fact that posting the calories here causes people to reduce their consumption of high calorie foods. So the idea here is that what you're trying to identify here is, do I have a movement or a shift? And the idea here, right, is that as you're reading this text, let's try to make this a little bit finer, is that as you're reading it, what you're seeing here is that you're basically reducing preferences for high calorie foods. Um, and what that would do is be a signal that you're shifting it. And by posting it, people are doing it less. So it's going to be a decrease. It's going to be affecting the demand curve. And so basically what you're going to be doing here as you're drawing this is you're going to be labeling the curve D2, but you're going to be decreasing the demand curve as you're reading this. Gosh, I hope this helps everyone. Okay. It's not going to let me keep this here. Okay, so every time I do this, it's going to erase this. So I apologize. I wish I kind of just kept it all the time, but it does not. Okay. So here in number 2, this is largely definitional. So I'm actually not sure much more I can add here, but I'll just kind of use this as an opportunity to remind us of the theory again. Is that when we learned about supply and demand, and we talked about what is it that causes this versus what is it that causes this. The idea here was that the demand function, which is a function of a bunch of different variables, one of them being the price of the good itself. When it's only the price of the good itself changing, That's our movement along the curve, which in essence is our definition of the law of demand. When I'm changing something other than the price of the good itself, such as income, that would be then where we're shifting the demand curve. And so then understanding each of these underlying variables and how they change things, that's where that would then be useful and necessary for understanding what direction you shift the curve. But to remind ourselves here we'd be saying that we have an increase in the quantity demanded, and here we have an increase in demand. Okay. So let's look at 3 here. In 3, what we're doing here is we're reviewing for ourselves how to move from individuals to the market. And all that we're trying to do here in number 3 is do a horizontal summation. So, in other words, what you would do here is that at the price of 12, we've got 12, right? And so the market here is formed entirely by Jim up to the price of 10. And then at 10, we start to get a non-zero number of quantity. And so without being incredibly precise here, because I don't have I can't see what the points are, but the idea here would be that you then will start to have a curve that looks like this, which is horizontally summing, for instance, that point of 4 and this point of 6. Sorry, I guess I really did miss. So it'd be 10, right? And the idea here would be at this price, you could horizontally sum these. So here I would have 3, and here I would have 4. Whoa. 3, and then here I would have 4, such that this is 7, right? And I would just keep doing that. And so that's what we're doing there, is we're horizontally summing these 2 demand curves. For number 4, this one gets a little bit tricky here, essentially because it's requiring that you start to incorporate the hog, the change in the price of hogs into things. So what we need to do here is, like, I guess kind of the question here would be is, how did they get from this to this? Well, the way they did that was, in this case, by substituting $1.80 per kilogram for hogs into the supply function, such that they had Q equals 178 plus 40p minus 60 times 1.8, which equaled sorry, even in my notes that I wrote for myself, it was a different iteration of this. So sorry, 60 times 1.8. So here I'm going to have 178 plus 40p minus 108. So that would be 70 plus 40p. Okay. So that would be my new supply function. when the price is 180 as opposed to when it originally was 150. Which would be my 178 plus 40p minus 90. And that would be where they got their 88 plus 40p here. But now, essentially, by raising the price to 180, this would be my new supply function, which we would put into there. So yeah, I solved it for you here, but again, the idea would be you're going to be a bit more comfortable seeing this again in the future. And yours might actually look different given the way that the system does things. Okay, number 5. So here we have a supply function for firm A and for firm B. And essentially what you need to do here is insert the price of 5 into each of these, substitute it in for P. So I'm not going to write it out for you here. But I'll write out the very general form here just to kind of start you off. The idea here would be is you'd have -2 plus 5. And for firm B, right, and then you would solve these and then add them to be able to get the market supply at the price of 5. And then you would repeat that again, in this case, for the price of 11. Okay. Again, I'm really hoping this helps. I actually appreciate feedback. If this is kind of helping you with how to approach these. For number 6, again, it's going to be a little bit harder here because I can't, put my cursor over something and see where I'm at here. But the idea here is the same. Okay, so now at the price of 4, I can see that both would have 2. So now I'm going to start at 4. Right? And at the price of 2, I'm at 0 and 1. So essentially my market here. All right, and I would start to combine these lines. Then at this price of 6, it looks like I'm at like 3 and 4, which probably is going to put me at about 7. Right, and it'd be, again, horizontally summing these. So at the price of 4, I know that my price or my quantity is 4. At the price of 12, I'm going to be horizontally summing 6. But now, it's not 6 and 10. Because we're told here that they can produce no more than 6,000 units. So in essence, what we see here is supposed to be a straight line here. Sorry, it's not going to look straight. It's not because I have a hand problem. It's just that I'm trying to do this with a mouse. It should be a vertical line at the limit of 6,000. That would be with the quota. So whereas here for the total price of 4, we're going to be at 4,000 units. At 12, we're going to be limited to 6,000 units for A. So in essence, for firm A, having to do 6. So that would mean then that, so firm A, let's call this firm A with quota, Q. That would mean that firm A at that price is going to have 6 plus 6, so that's going to equal 12. Okay. Number 7. Every house has a well. 10,000 gallons a day. Then it has to buy water outside of town. Town currently consumes 7,000 gallons. Okay. So that would mean that to supply out to 7,000, the price is 0 because people are getting it for free. Sorry, 8,000 here. Looking at my notes of what I had. So at up to 8,000, they get it for free. Then if it wants more than 12,000, then it has to buy it. So that would mean in terms of the supply function, it would look like this, right? Where supply is 0 all the way down and then supply. The demand, on the other hand, I mean, we don't really know where the y-intercept is here. We don't even really know where the y-intercept is here. What this is really trying to focus on here is the x-intercepts. So it's a little bit deceiving about this question if you wanted my opinion, and why it's not a question you would see on the exam, is you don't have enough information to know what the magnitude of the slope is for each of these. Really all you have is enough information to say what the x-intercept is for the supply curve and the demand curve. So what's the equilibrium quantity? In this case, it's going to be the x-intercept of the demand curve because the price is 0. So that would be my 8,000 gallons right here. And the equilibrium price would be that $0 price because it's still what people can do with their well. Then, if anyone's thinking anything weird here, I remember thinking something was weird here. And that would be relating to why does this author like to talk about hogs so much? I can't answer that, but he really, really, truly does. Okay, let's look at this. So we've got a price here of $4.94 minus 17p plus 20 pb plus 3 pc plus 0.002y. Then we have our supply function for pork. So the idea here is you're going to substitute in these relevant prices into your demand function and supply function. And then you're simply going to solve for equilibrium price and solve for equilibrium quantity. That's all you really need to do here. This is related to number 9. Number 9 is asking you to do these things in general form. I'm not going to ask you to do that on the exam. My whole point here in this course is not to make you mathematicians. If you wanted to be a mathematician, you would take a class called Mathematical Economics. That is not this class. We are intermediate microeconomics, and really the point here is to get you to start to think in terms of mathematical metaphors, start to think in terms of mathematics. And so what we're going to do here for this is so that if my demand function has a general form with a constant term and a slope term of b, and my supply function has a constant term and a slope form of e, then what we know is that solving for equilibrium is that A minus BP would equal C plus EP. So then if you rearrange the terms and solve for P, then the equilibrium price, right, which would be what you're solving for here, would simply be in the numerator, you'd be subtracting your constant terms, and in the slope, you'd be adding your slope terms. That would get you the equilibrium price. And without going into all the dynamics here, you'd be able to, right, we could add BP to this side, right, and then just solve for P, and that's how I got my equilibrium price. Then you would substitute this into either equation. And when you do that, AE plus BC over B plus C. This is not that important, to be honest. Just get through this, and it just kind of convinces you that you don't necessarily need numbers, that you can work through this in other ways. Okay, number 10 deals with this issue of ethanol, and it's both an input for making fuel, and it's as well as it's something that's eaten. In this case, what's going to happen to the price of corn and the consumption of corn if more corn is being used to make ethanol? Then the effect that that would have is it would reduce my supply for corn as a food, because now more of it is going to corn as a fuel, which would mean that my price is going to be going up and my quantity is going to be going down, as is kind of implied here. Then we need to look at this supply function with natural logs. Dude, don't worry about it. You're not going to see this again. This, again, is a rare, not a rare instance, but a hopefully not a frequent occurrence where the author really wants to make you a mathematician. And I do not think that that is necessarily the case. So here you would have to think back to high school and think back to logs and natural logs. Don't worry about it. Hopefully the homework system should give you enough tips to work out through this. Basically, the natural log is the log of e being a mathematical constant term. And that would be the way that you would find that, at least in this case, that if the price is going up, what we know is that the equilibrium price is going to be going up. Just in general terms, we would know that to be the case. But you would need knowledge about natural logs to be able to say how much it would change by. Again, you're going to have slightly different numbers if it's being algorithmic about this. Okay. Here in number 12, this one actually applies a great deal to Hawaii, given how much we require occupational training and occupational licenses. Here, what we'd be seeing here is that the supply is shifting to the left. Now, the reason why the supply is shifting to the left was we were saying here that that was the intent here of having exams, is that fewer people are going to be willing to take the exams. But what it's asking us in this question is, what if making these people take exams had the effect of increasing the quality? Well, the idea here is that people would want more, they would want more workers that are of higher quality. So the idea here is that the demand is also going to be increasing at the same time as supply is decreasing, which would mean that both our equilibrium price and our equilibrium quantity is going to be increasing, so long as our shift in demand is greater than our shift in supply, which we kind of have to assume is going to be changing here. Now, these are all sort of definitional, or at least 13 is sort of definitional, so I'm hoping I don't have to add too much to this here, but the idea is that, again, as heartless as it sounds, that if you have a disaster, the politicians will step in and say that we need a price ceiling. A perfect time where that happened was during COVID. But what we see is that it does create shortages. So from that, you should already be able to cross out options A, C, and E. And then all you really need from that then is just to see what is the definition of a shortage. And the definition of a shortage would be where more is demanded than supplied. Okay, number 14. Number 14 here is that what you need to do here is shift your demand curve, because in this case, you've got a price ceiling imposed here, but then the winter is a little bit warmer. So now we have less demand, which means, right as you're drawing this out, that the price ceiling is not going to be meaningful anymore. And 15 again should hopefully just be definitional, as should 16. And that leads us to number 17. The trick with number 17 is that we have a differential shift happening here. And so if you think back to Econ 130 and 131, is that with the differential shift, what we're seeing here is that while the while the demand curve is, the supply curve is increasing because you've got people with more Russian-made weapons and soldiers giving it up. And so right here they say like hundreds of thousands of firearms. So the prices should be going down. Why aren't they going down? Because what's happening here is demand is increasing by much more than what supply is shifting by. And that's the information that you need to answer this question here. And Then in 18, what we're relying on here is that if I impose a minimum wage that's above the equilibrium, then what we would see, as is typically the case with the minimum wage, is that there'd be a surplus of labor or an excess supply of labor, where our amount of unemployment is going to be the difference between LS minus LD. And then the question then becomes, who does the minimum wage help and harm? And in this case, it's going to help those who are lucky enough to get one of these jobs that pays so well. And it's going to harm those who are unemployed because they'd be willing to accept less, except no one will hire them with that amount of less money. Okay, I hope this helps make working through these homeworks a little bit less frustrating.